In this video, I'd like to talk about the math question of the day for Sunday, July 23rd, 2023. And with this problem, we have an integral of a product of the sine and cosine function where the input is different for each of these. And questions like these are typically seen in a Calculus 2 class. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start going through this. And whenever you have this product here of sines and cosines, and they have different inputs, we can use trig identities to change this to a sum. So let me paste in these identities. And we have a list to choose from, but we have a cosine multiplied by a sine, or sine by a cosine. It doesn't matter. We can use either of these. So we can rewrite the cosine of 3t multiplied by the sine of 8t. And we're going to use, let's say, this identity here, but it looks like we can use this one as well. But we use the bottom one so that we get theta in our formula equal to 3t and phi is equal to 8t. So plugging these in, we have the sine of the two angles added together, 3t plus 8t, that'd be 11t. And then we subtract the sine of 3t theta minus 8t phi, which would be negative 5t. And then all of this is divided by 2. Now, if we want, we could also use another trig identity that the sine of negative theta is equal to the opposite of the sine of theta. We can use that here so that we can essentially drop both negative signs. And what we get is 1/2 the sine of 11t plus, now we're making this angle negative, so it becomes minus the sine of positive 5t. We're just changing the sign and using this identity, and that negative would cancel with this negative. So we get plus the sine of positive 5t, and that is also multiplied by half or divided by 2. Now, we want to find the integral of this expression with respect to t, so let's now rewrite everything using this new identity. We have the indefinite integral, and we can factor the 1/2 out. We have the sine of 11t plus the sine of 5t. Let me rewrite that a little bit neater. And all of this is integrated with respect to t. Now, at this point, we could separate these into two distinct integrals, since we'll need to do a substitution in each. We have 1/2 the integral of the sine of 11t dt plus 1/2 the integral of the sine of 5t, and we have dt still. Let me just make a bit more room and clean this up. Now for this left integral, we'll set u equal to 11t, so that du is 11 dt. And for this integral, we can set u, or maybe we can call it v, equal to 5t, so that dv is 5 dt. And we're substituting for dt in both of these, so we'll have to put the coefficient on the other side. So it really becomes dv over 5 is dt, and for this one we have du over 11 is equal to dt. So let's now plug everything in for these new substitutions. We would have 1/2 still up front, but we're substituting dt for du over 11, so we can put that 1 over 11 out front as well. So then on the outside, we get 1 over 22 multiplied by the integral of the sine of u du, and then we add this second integral. And since we're replacing dt with dv over 5, the 1/5 can go on the outside, so we get 1/10. And this is the integral of the sine of v dv now. And simplifying everything, we can actually compute these integrals we have 1 over 22. The integral of the sine function is just the negative cosine, and this is in terms of u, but we know u is just 11t, so we can put that back in. And then we add 1/10 multiplied by this integral, but we know that this evaluates to the negative cosine of v, and v we know is just 5t, so we can plug that back in, and we'll have our constant of integration c, since this is an indefinite integral.